Hey you guys, so hopefully this video will help with the start of section 8.4, which is called parametric equations. We will cover the rest of it on Monday, but this should get you through the homework and get you a good start on it. So I've got an example here if you want to copy it down into your notes. This might be the first parametric equation you've ever seen, right? And what it is we have essentially, we're going to have a graph where the x values are defined as a function of t, and the y values are defined as a function of t. So we kind of get this, x equals f of t, and y equals f of t. We call t the parameter. So t is called a parameter. Okay, all the t's are, I just pointed to that one. So the parameter, it's easy to think of it as time. And that's often what we use, but it's really just kind of a measurement where we plug in values of t into both the x and y equations, and then we end up with ordered pairs x, y that we can use to graph the function, right? And because it has this parameter, because these t values are there, the graph we end up with actually has a direction. Okay, so the way to graph this is we make a big table, and this table has 3 columns, t, x, y. Okay, now in the parametric equation, it really has 3 parts. It has the 2 equations, but then it also has the restrictions on t. Okay, so I could plug in any values for t from negative infinity to positive infinity to keep them on this graph. I'm going to start with the t value of -1 and work my way up. -1, 0, 1, 2, 3, 4. I think I want to do stop there. Yeah, I'm going to stop there. Okay, so all we do is plug those into the x function. So I do t squared minus 3t. All right, so you go through -1. So 1 plus 3 would be 4. I'm just plugging it up here. 0 minus 0, so 0, and then we'd get 1 minus 3, be -2, and then 4 minus 6 would be -2 again, and then we get 3, so 9 minus 9, oh, it's 0, and then 16 minus 12, oh, it's 4. Okay, some symmetry there. Then for the y values, we plug into the y equation. Okay, so let's see, t is -1, minus 1 is -2, and then 0 minus 1 is -1. Make sure you're going back to the t values, not the x values. 1 minus 1 is 0. Looks like a pattern here. 1, 2, 3. Okay, so these that we've created here, those are ordered pairs, right? Ordered pairs. Okay, and so we're going to plot those points on the graph. So I'll start with 4, -2, then 0, -1, -2, 0, -2, 1. Hold on. There's -2, 0, there's -2, 1, 0, 2, and 4, 3. So hopefully you see or are thinking, yeah, it looks like a parabola, and it is. Okay, so we could, that vertex is certainly happening somewhere between those 2 points. So we could plug in 1.5 and get the vertex. I'm not too worried about that right now. So I'm going to graph, and what we do here, we make this parabola, goes like that. Since the t values are from -infinity to infinity, it's going to continue both before where we started at this first point and after where we finished. So we can continue this with arrows, but you have to be really careful. This graph has direction, okay? And so when we do that, that arrow is going to go like this, right? Think about why the arrow would be facing the direction I'm pointing it in, all right? As t got bigger, the points sort of traveled along in this path, okay? Moving from 4, -2 to 0, -1, and so on all the way through it. Okay, that creates the shape, but because it's a parametric equation, because this t value is creating the x's and the y's, this graph has directions. So that very first arrow you draw cannot be facing the other way like we're used to. It's got to be facing the direction that the graph is going. Okay, so there we go. That's our first parametric function that you've graphed. Let's try another one. Okay, this example here, we're going to do something called eliminating the parameter. So essentially we're trying to get it back into rectangular form, all right, which means no t. And that we're there eliminating the parameter, we're trying to get rid of t. You'll notice these are the same two equations, x equals t squared minus 3t, and y equals t minus 1. So the way this works, it's very similar to solving a system. Okay, I just want to somehow get rid of the t. So I want to find the easiest t that I can solve for, and in this problem, it's from my y equation. So I would get that t equals y plus 1 just by adding 1 to both sides, right? And now I can substitute that into there and there. So I'll get x equals y plus 1 squared minus 3 times y plus 1. All right, so now some of these equations you'll be able to get into a nice y equals form. This one we won't, but we can expand this out and simplify it here. So x equals, that's going to be y squared plus 2y plus 1, and this will be minus 3y minus 3. And if we combine those like terms, we'll get x equals y squared minus y minus 2. And that's going to be it's a sideways parabola, just like we saw on the previous slide here. So we can leave that answer there. One thing you do want to pay attention to is if there is a restriction on t, that could potentially lead you to needing to write a restriction on the x and y values, or the domain and range of our rectangular equation. One last example here, finding a parametric equation for a graph. So on this video and in your homework over the weekend, we're going to stick with just lines, and then on Monday we'll talk about some different types of graphs for writing an equation. When we write the equation for a line, we're really going to think about having a starting point and then a rate of change or a slope from that point, okay? So it's a good idea to have a little mental picture of what's going on. So if in this example A, I'm starting at the point, or it says through 2 comma 6, so 1, 2, and then 1, 2, 3, 4, 5, 6. So I've got this point, and the slope's going to be 3. So that slope means I'd go up 1, 2, 3 over 1. And that would be my next point. Now, based on what the information we're given, it doesn't tell us a direction. So we could actually pick whatever direction we wanted. All right. I like to pick one point as my starting point. So let's take the point 2, 6. And you can arbitrarily give it a t value. So we'll say that's going to happen when t equals 0. Right, and we could pick any t value we wanted for the next point, but an easy one to pick is t equals 1. Okay, so that first point, like we said, was 2 comma 6. The second point, we've gone up 3, so the y value is now 9, and we've gone over 1, so the x value is now 3. So the equation we would write is x equals, start with its starting value. The starting x value is 2. And then every 1 unit of t, we're going to go up 1 unit of x. So x went from 2 to 3 when t went from 0 to 1. So it's just going to be 2 plus t. So we're going up 1 unit for x. Now the y equation, my y value goes from 6 to 9. So my y value starts at 6, and it goes up 3 units for every 1 unit of t. So I say plus 3t. Now what's kind of nice about this, if you think about slope as being y over x, I can sort of divide the 3t by the t, and there's 3 over 1. That's my slope, right? So the final thing, when you write a parametric equation, you do need to write out the values of t that are in play. Here we're not told anything, any restrictions, so we'd say negative infinity is less than t is less than infinity. okay? And because of the way we chose t to be going from 0 to 1 in this direction, we can put arrows on here going in that direction. The other way is here starting at a point 4 comma negative 1 and going through 1, 7. Okay, this is important language here. It's starting at 4, 1, negative 1, so it doesn't have anything before that. That's the very beginning of this line. So 4, negative 1 would be right there. And then goes through the point 1 comma 7. So here's 1, 1, 2, 3, 4, 5, 6, 7. There's that point there. Okay, so really, if we're thinking of it starting at 4, negative 1 and going through that point, it's not really a line, it's a ray. And we're going to do the same thing, though. We're going to call it this initial point t equals 0, that next point t equals 1, right? 4, negative 1, 1 comma 7, and we can write the equation the same way. X equals, first x value is 4 plus, and we go down 3. My x value went from 4 to 1, so negative 3t. You could obviously just write minus 3t. And then y equals, the first y value is negative 1, plus we go up 8 units for y to get from negative 1 to 7, so plus 8t. And my restriction on t is going to be greater than or equal to 0. T is greater than or equal to 0. All right, that's all for this video. So try out the homework problems, and we'll talk about this more on Monday. Thanks for watching.